about it every day in the news, in all kinds of scenarios. It's politicized, etc. But I want to just talk about the current situation as I see it, and in the context of the current situation of the global energy landscape, talk about our capabilities at Texas A&M and with the Texas A&M University system. As Dr. Ochoa said, one of my titles, one of my positions is at the system, so I work with the entire system, not just Texas A&M. Then I will transition into talking about the Energy Engineering Institute, which was formally created last December, so it's very new. And then I'd like to talk about your role in the future of energy. You're going to see how complicated it's going to be, almost kind of scary. Now, to put this in context, of course, we're very familiar with the fact that BP had a major oil spill. And you all are engineers, I'm an engineer. We can look at the technical challenges of this explosion. But as you can see in the next few slides, or as you will see, there are many moving parts in this factual scenario. So the explosion took place. You had to get emergency response people in. They're not engineers. They may not have even graduated from college. Safety engineers or safety personnel. And how do you communicate between parties during such a scenario? The computer science department here, for example, has a major initiative on emergency informatics and how law enforcement and engineers, politicians, etc., learn how to use social media and other communication means during an emergency situation. So this is very challenging. We also have the technical challenges, and we read about this every day in the paper. The immense anxiety unpacking this well was tremendous. I spent the entire summer on this, and I won't get into that, but it really ate up a lot of time. But the technical challenges is something we'd be interested in as engineers, of course, but I want to convey that there are many other moving parts. We have environmental challenges, obviously. So daily we saw the reports in the news about how the oil spill is damaging the coast and also the wildlife and marine life. And there's a reason I'm showing you all this. And then the human health aspect as well as mental health and the economic impact. And so as engineers, if you work in the energy sector, which is highly probable, you have to understand all these moving parts, including politicians. We have lots of boundary conditions on how to solve this type of problem. And I think part of the delay of capping the well had to do with not in my backyard issues, this is not in my jurisdiction, communication issues, trying to convey what's really going on versus what's the perception, etc. And then you have leadership challenges. Are you positioned as engineers to be future leaders in the energy sector in some way so that you can make wise decisions immediately? So, we have this type of emergency that just took place, but we also have a national conversation that's going on. August of last year, the National Science Board, which is the governing body over the National Science Foundation, and by the way, the current chair of the Science Board is the former president of Texas A&M University, Ray Bowen, Dr. Ray Bowen. He was a faculty member in this department, right? Still is. And they issued this report, which you can download online if you go to the NSF website, nsf.gov. But look at these recommendations. I mean, it's really a report. It's an urgent message that the United States should look at how to prioritize funding, really Congress, how it needs to prioritize its funding towards research, development, demonstration projects, deployment of the project, and education. Now, in universities, we look at the basic research, but how do we take this basic research into practice? And that's something I'm going to talk about today. The National Academies also issued a series of reports, which you can also look at online, and you can download these, but there is a cost to it. But again, you see a similar sense of urgency in looking at not only the national security issues, but the economic impact and the environmental issues as well. But note the quote here, our energy system. As engineers or as researchers at the PhD level, we may be doing research on nanocomposites or a solar cell design, or maybe even a bioconversion process like Dr. Anomaly does in his lab. But when you integrate your work into an energy system, what are the unintended consequences of its performance success? If you plug in a new solar cell design into a solar panel and then integrate that solar panel into some sort of residence or commercial entity and integrate it with the electric grid, which by the way is aging, how is it going to perform? Is it going to perform the same as in the lab? So we have to look at energy systems. And we also have to look at the society's economic, social, and political arrangements. If you design a new solar cell, maybe it's too expensive. Maybe people don't want to put solar panels on their homes. So what good is your technology if people are not going to embrace it? And then the National Petroleum Council. I can go on and on and on. The National Petroleum Council, I happen to be serving on a subcommittee of this council, an advisory council to the Department of Energy, to the Secretary of Energy. In 2007, they issued this report, which you can download for free. And it's a report on the look at the global oil and natural gas future out to 2030. So this committee of very intelligent people from industry, universities, government, etc., took a hard look at, based on engineering practice and knowledge, what is this scenario going to look like out to 2030. What we're working on now as a committee is what is going to be the portfolio of fuels out to 2050. Is it going to be just oil? And the answer is no. Is it going to be a biofuel? Is it going to be natural gas that's converted to some sort of liquid? So we're looking at all of these issues right now in the current committee. Then, when we look at energy, if you look at bioenergy, the electric grid, what's the source of energy, you're going to have water challenges in many cases. And so there's a trade-off between an economic source of energy and how you distribute it, and the question of whether or not there's enough water to support that industry. So sometimes there's an unintended cost. And what about the environment? This is another report you can download from the NSF website. I just wanted to show it to you because with environmental issues, whether it's actually on the land, in the water, or the climate, again, there are unintended consequences of some of the new energy sectors we're moving into. For example, if you're looking at solar cells, the manufacturing process for semiconductor-based solar cells involves toxic chemicals. And so if your manufacturing process is not green, there are unintended consequences to the environment. So cost, efficiency of the solar cell, and is it manufacturable in a green way? Lots of interplay in issues here. Sounds a little scary and overwhelming. But how do we fit into this context of global energy and the challenges that we face? Okay, like I said, I have a role at the system. Now, I highlighted in red Texas A&M. That's where your students here. We also have the state agencies. How many of you have heard of the Texas Engineering Experiment Station? Okay, how many have not? You may actually be